For decades, physics has been kind of stuck on some really big questions. But what if the problem isn't the math? What if it's the entire philosophy behind how we do science? We're about to dive into a radical new way of looking at reality, one that's being championed by a group called the Conjecture Institute. And trust me, it challenges everything.
It really all boils down to this one question. Is a scientific theory, say like Einstein's relativity, just a fancy calculator, a useful tool that helps us predict stuff? Or is it telling us what the universe is actually like? Your answer to that question? Well, it changes absolutely everything.
So, on one side, you've got the mainstream view in physics today. It's called instrumentalism. And the basic idea is, hey, if the math works, if it makes good predictions, who cares what it means? It's a tool, end of story. But the Institute, they're on the other side. They're realists. They say that's not good enough. A theory can't just be a good prediction machine. It has to be a true explanation of reality. It has to actually make sense.
Okay, so here's how we're going to break this down. First, we'll dig into this core conflict between the two camps. Then, we'll look at their completely new operating system for reality. We'll see what it means for the absolute weirdness of the quantum world, how it could totally upend our ideas about time, and finally, how all of this leads to a surprisingly simple $7 million experiment. And look, this is not just some small academic squabble. The way the Institute sees it, this is a massive fork in the road for our understanding of the universe. It's the difference between just wanting useful predictions and demanding deep, meaningful explanations. So the main tool they use to build these explanations is something called constructor theory, and this is so cool. Instead of trying to predict what will happen next, it flips the script and focuses on what can happen, and, just as importantly, what can't. It's a whole new way to write the rulebook for the universe. All right, let's get into how this thing actually works. Don't think of it as just a new app for physics. Think of it as a whole new operating system for reality itself.
So traditional physics, right? It's all about give me the starting point, the initial conditions, and I'll apply the laws of motion and tell you what happens next. Simple. But constructor theory couldn't care less about what happens next. It asks a deeper question. What are the fundamental principles that make certain things possible and other things totally impossible, period? It's like the difference between predicting the next move in a chess game versus understanding the underlying rules that allow the pieces to move in the first place. And believe me, this isn't just some abstract idea. This new way of thinking could actually solve some of the biggest puzzles in science. We're talking about unifying our understanding of information, both classical and quantum, fixing long-standing problems in thermodynamics, and even explaining how something as complex as life can pop up just from the basic laws of physics. That is a huge deal. Now let's take this whole approach into the bizarro world of quantum mechanics. The Institute's argument is that for a century, we've been using quantum theory like this weird, magical calculator. But it's time to actually take it seriously, as a literal description of what's going on down there. I mean, this is the classic quantum head-scratcher, isn't it? You've got a particle that can be in a whole bunch of places at once, but the moment you look at it, poof, it's in just one spot. So what's really happening? Where is that thing when you're not looking? Well, the standard story uses a kind of patch, this idea of a collapse. It says that the act of measuring forces the particle to choose one spot. But here's the thing. That's an ad hoc rule. It's something tacked on because it's convenient. It doesn't actually come from the core math. The realist view, the one the Institute holds, just follows the math where it leads. And where it leads is the multiverse. Every single possible outcome actually happens, each one in its own parallel universe. Now that sounds wild, I know. But it's not a new theory they just made up. It's what the math has been telling us all along. And the Institute is really firm on this. They basically say, look, if you're a realist, if you believe theories should be true, you don't really have a choice. The many worlds interpretation is the only one that takes the theory at its word, without adding any extra made-up rules. Oh, and this framework also cleans up another huge quantum mystery. You know that thing Einstein called spooky action at a distance? Well, their work shows that the universe is actually fundamentally local. Those entangled particles aren't sending secret, faster-than-light texts to each other. Everything only affects its immediate neighborhood. No spookiness required. So, if you're on board with this realist picture so far, well, buckle up, because this is where it starts to challenge some of our most basic, everyday feelings about how the world works, starting with time and chance. We all feel it, right? Time is like this river constantly flowing forward. But according to this research, at a fundamental level, time doesn't exist. It's an abstraction. Instead, what we call change is just physical systems, internal clocks, changing relative to each other. There is no giant master clock ticking away outside the universe. And here's maybe the biggest mind-bender of all. In this worldview, there's no such thing as true randomness. The universe is completely deterministic. When we flip a coin, that 50-50 probability isn't a property of the coin. It's just a description of our own ignorance. We don't know the exact spin, the air currents, all that stuff. If we knew everything, the outcome would be 100% certain. This view says that's true for the entire universe, even at the quantum level. Okay, I know this all might sound like super abstract philosophy, but here's where it gets real, because it leads directly to a totally new and much smarter way of thinking about experiments. And it's all guided by this philosophy they call applied optimism. It's a simple but powerful idea. The best way to solve problems isn't to just throw billions of dollars at them. It's to first get smarter, to create better knowledge and better explanations. It's about being clever, not just rich. And this experiment is the perfect example. So to test if gravity is quantum, the usual idea is to build another gigantic multi-billion-dollar particle collider. The Institute's proposed BMV experiment, though, is so much more elegant. It asks a simple question. Can gravity itself cause two objects to become quantumly entangled? If the answer is yes, then gravity has to be quantum. Boom. It's a clean yes or no test based on a deep, simple principle. And the price tag for this profound reality-checking experiment? Roughly $7 million. Let's just put that into perspective for a second. We're talking millions, compared to the billions of dollars needed for a new particle collider. This is applied optimism in action. It's about solving a problem with a better idea, not just with more brute force. So, after all that, what's the new picture of reality we're left with? Well, according to the Institute, it's a world that's local, no spooky stuff. It's deterministic. Nothing happens by pure chance. It's timeless. Change is just a relationship between things. And maybe most important of all, it's comprehensible. It's a universe that isn't just a random collection of rules, but something we can genuinely understand. And all of that leaves us with one final, fascinating question to chew on. If this picture of a deterministic, timeless universe is actually correct, what does that say about our own, deeply felt experience of making choices and our sense of the passage of time? It's a question that takes physics right out of the lab and into the very heart of what it means to be us.